Hi guys, welcome back to my YouTube channel. So on this week's video, we're going to be working on a fully autonomous self-driving car using the Sparkfun Inventors Kit version 4.1. On my last Inventors Kit video, I teased that I would do this on my remote control car video using the same kit from Sparkfun. You guys should totally check that out. So I built it, and it's not unlike the one from Tesla, so here it is. So here are all the parts we're going to be needing to build our self-driving car. So we have our jumper wires, we have our ultrasonic sensor, which will be able to tell distances and help our car actually steer and not run into a wall. We have our motor driver, which connects the signals and the voltage to the motors that control the wheels of the robot. Here are the two motors that control the robot, and here are the wheels also that latch on to the motors. Here is a 3-pin momentary switch, which is pretty common for any Arduino based project. This will serve as the on and off button for our robot, so we don't want it on all the time. And here is our 4 AA battery pack, which comes up to our 6-volt battery pack, which powers our Sparkfun red board and breadboard right next to it. So this is our wiring diagram and our hookup guide, so you guys know exactly how I did this, so you guys can do it at home. So here are our motors and where they're connected, and our motor driver, and this is our Sparkfun. This is the red board, this is the breadboard, the switch in the ultrasonic sensor. So the jumper wires go from 5 volt from here, 5 volt to here, to 5 volt to here, and they also go ground wire to ground wire negative, and then we have our VIN going all the way to A1 up here on the motor driver, and then we have pin D8 to J5, and then we have D9 to J6, J6, D10 to J7, D11 to J1, D12 to J2, D6 to E18, D5 to E19, D13 to J13, D7, pin 7, all the way to I27, and then 5 volt positive, we're connecting them right here. Positive to give power to both sides of the breadboard. And then we have our ground wire, which is our negative to both sides of the breadboard again. Then we have pin A2 to 5 volt plus. And so our A2 pin, which is here, goes into our 5 volt, which comes directly from the breadboard. Then we have our A3 pin, which is, again, our ground, which is our negative. Whenever we have a positive, we must have a negative. And our J4 pin on our breadboard, which is connected to the motor driver, goes to positive 5 volt, and then I26 is our ground negative that pairs it to the J4 5 volt. And then our E17 to 5 volt, E17 to 5 volt, and E20 to ground. And then for our motor, we have A4 is the red, positive, and A5 is the black. A7 for motor 2, which is the left motor, A7, red, A6. And then our motor driver is C1, C8, all the way through G1 to G8, where we connected all of those to our signal pins onto our breadboard. Our switch right here is F2 to F5 plus F25 plus F26 plus F27. Our distance sensor is plugged in at A17 for our VCC, A18 for our trig, A19 for echo, and A20 for GND. So here is our code. I'm in the Arduino processing software, and we can see our starting setup where we put our control pins and where our pins will be controlled using the motor driver, and which pins are the switches in, which pins are the ultrasonic sensors in, and our setup is where we're going to send our ultrasonic pulses, begin serial communication with the computer. And so in our main code, which is the void loop, we're getting the distance read by the distance sensor. We print the units on our serial commander, and then it detects if the on switch is flipped, and then it will turn on the entire robot. And then we have our object detection, which basically controls our autonomous driving. And then our off switch is stop. And then we have a 50 millisecond between readings for distance. Then we have motor functions for driving the right motor, for driving the left motor, for going left, right. Having our ultrasonic sensors and storing it in a variable to take the ping to bounce off an object. And this is basically our code. And so this is our serial monitor. And we can open it, and all of our, just like our code says, all of our distances will be placed in there. Thank you guys so much for watching. Thank you for your amazing support that's helped me and my channel grow from 0 to 50 subscribers. Again, I wouldn't be here without your guys' amazing support. As always, like, subscribe, hit that notification bell to stay tuned for more awesome videos like this. Go follow me on Instagram at GsFunV. Make sure to drop cool build ideas that you guys want to see me build in the comments below. See you in the next video.